Can someone remind us what we did last time we were here? Last week we had a holiday. The funny thing is that I wasn't aware of the holiday. Personally, my mind was not even aware that there was a holiday. But then, very early in the morning, as I was waiting for the class, I remembered that it's Mashujaa Day. So I had to write something on e-learning. I hope you looked at it. But before that, we had a class the previous week that is on 13th of October. And I don't know whether anyone can remember what we did. So what were we discussing? Because it will be something that we're going to build up on and then continue discussing today. I hope you still have the bigger picture in mind, right? Up to now, we are just compiling our programs, right? So we've written lines of codes and we are trying to compile them, right? So we said that there are several processes that are going to be involved. Practically, we said that they are going to be split into two major groups, right? There'll be the front end, and then there'll be the back end, right? There'll be the back end, right? And here there is an intermediate code representation, right? IR. So we have that, we have that, we have that all the way to the end. And obviously here we have errors that can lead up like that, something like that. Right. So we are still here. Now we said that the front end is governed by some form of rules. Okay, so it's a bit easier to even design. That's the reason why you tend to find that the front end doesn't change that much. And even when you're designing your own compiler, okay, based on the tools that I've given, I don't know whether you've tried to design some of the phases that we discussed. You tend to see that this front end is governed by rules, right? There are things that you have to do the other way that way, right? But the back end, as you'll see maybe later on towards the end of the course, you'll see it's a bit unique in its sense, and it's also a bit more complicated. This one is governed by a set of rules. If you remember what we did the other week, we were doing something called scanning, right? So lexical analysis, right? So the Lexa. So what we are trying to do is that we had the lines of code which are broken down into tokens. Obviously, before they were broken down into tokens, we had the legsmis and all that. Technically, you have to talk about those ones. And then after that, have the tokens. And then after the tokens, those are the ones that are fed now to what we are talking about today, what we call the PESA, right? That is syntax analysis. Okay, so that is what we're going to talk about today. Now, what do you think is going to happen now? The phase that we are in right now, what we are calling, let me take my text, what we are calling syntax. Can you hear me? People have gone silent. Maybe my network is off. What do you think? What do you think we're going to be doing in the syntax analysis? So right now we've broken down our program, our lines of code, right? Then terms of tokens. Now, if you've gone and looked at the material that I was highlighting before, because I can't cover everything, okay? What I always give is I always give what I think is important, right? And then after that, for those who are interested in the area, they can go and look for more material. You realize that even though we only spoke about tokens, okay, in a very shallow way, you realize that those even tokens are even actually converted to their binary equivalent, right? So sometimes even the numbers, right? Because that's how the computer is going to understand them. It's not going to understand this, okay? Even if it's something like this, consider this. It's this that we are breaking it down, right? If you're breaking it down based on the grammatical rules of the English language, the grammatical structure, right? So maybe you may split that way in terms of the words, each holding its specific value and action or whatever it is, right? So after breaking it down into that, right, the computer does not understand these words, right? So it understands numbers, right? Binary to be more specific. So they have to be converted in terms of tokens, in terms of those numbers. I'm hoping someone went deeper and found that, okay? You can even go and maybe try and scrutinize and see how you can make one lexical analyzer more efficient as compared to another. Anyway, so after getting the tokenized program, okay, or the tokenized content, it brought the syntax analysis or syntax analyzer to be checked for any errors based on a certain set of rules that are there for given language. Okay, so in simple terms, we are moving from the lexical analyzer into the scanner to try and check whether our program, the one that we've written, the lines of code, whether they are following the rules that are predefined by a certain programming language. Okay, so let's start with the English language for a minute, right? Just for a second. There's a certain structure that is followed I actually just met this the other day. I was trying to prepare for this class. Take for example this sentence: the dog sat on the floor. Let me use the mat. The mat is better, right? So if you remember your English language when you are learning it, maybe in class 4 or 5, I don't remember when, you are told that there are several structures that are followed when you are writing a sentence in the English language. Okay, so those are the rules that are there. One of them, you are told there should always, in a sentence here, there should be a full stop. Don't forget that. There should always be a subject. This is our subject. Okay, there should always be a subject. Okay. After that, there needs to be a verb somewhere, right? An action. Okay. And then after that, at the end, you need to define an object. Right. So I'm not saying that this is the only structure that is followed when coming up with a sentence, but for this context, let's just choose this one. Okay? So you can see there are several items that are needed there. You need to have a subject, you need to have a verb, you need to have an object. So those are the rules that are being followed in this case. Okay. Even this sentence here, though it may seem a bit weird, is also true. So something like the cow jumped over the bus. Okay, so even that sentence, even though without being given a context, it may seem a bit weird, right? That sentence is syntactically correct, right? Because it follows all the rules of this given structure, where there is a subject, right? There is a verb, right? And then at the end, there is an object, right? So in terms of the syntax rules, right? These two are correct, right? Even the second one, if you are to follow and go even further and check for the semantics, right? The meaning, okay? Maybe in a certain context, you may realize that maybe the word bus stands for something else. Maybe it's a line or something, right? But if it's in the context of a bus being the physical bus, right? Then this one maybe semantically may not make sense. But you get what I mean. I hope that is understood, right? So using the same analogy, right? Using the same analogy of the English language, right? We have to have a set of rules that are going to govern whatever programs you're writing. Okay? And these rules have to be predefined. That is the item that I need to emphasize. They have to be predefined. They have to be predefined so that there is no disagreement between the programmers. Okay. I don't think there is any time you've ever met two programmers that are arguing over the syntax of a certain programming language. They're always in agreement. Right? So it has to be in agreement with the programmers and also the programmers who write the compilers themselves. Okay, because if there's a disagreement between the two, whenever one writes a certain program and then they come to compile, there'll always be errors. Okay, so there have to be there have to be an agreement. There has to be an agreement. Okay, so when you are designing a programming language, I remember there's someone who asked that question: how can I design a programming language? In essence, what you're trying to do is predefine the predefine and come up with. Okay, now sorry for that. Hope you're still there. Oh, okay. Let me hope that doesn't happen again. Good. So where was I? Okay. So I was saying, okay. So if you want to come up with your own programming language, right, or you're coming up with a programming language, right, what you're trying to do in essence is come up with the syntax rules, okay, which we are saying in any language, in any programming language, they are always predefined. Why? So that there is a form of an agreement between the programmers and also the programmers who are going to write the compilers themselves. Okay. So in that case, right, what you're coming up with there are the syntax rules, and we said that there is a system that is followed, okay, so that you can come up with those rules, what we call CFG, right, the context-free grammar. Okay. How many remember the 4 tuples that were defined in CFG? If you remember them, write something on the chat. Write something on the chat. I know we are together, right? The CFG, right? On top of that, right, when you are defining these rules, right, you need a common notation. Okay, you need a common notation, a common way of writing down these rules. Okay, and this is where, if you've ever heard of this term, Bocas norm. I don't know how many times you've heard of that statement. Bocas norm. Okay. In short, BNF. BNF is a notation that is used to describe CFG. Okay. Now, since I want to see whether we're in class, okay, I want us to spend the next 1 or 2 minutes. Just go and check what Bacchus norm is, okay, and then come back and report. Okay. I hope you are still in class as I check on my network. Right. We are trying to highlight this major phase of the front end in compilation of programs, which is called syntax analysis. Okay. I hope you are still together. I see so many people are joining in the class late. Okay. So if you're just joining us, we are saying that we need a set of rules to govern us when we are writing programs, right? These rules are always predefined for certain programming language. Okay, and I'm going to elaborate later as to what I mean by that. Okay. Now, the reason why we have to predefine these rules is because we want to have an agreement between different programmers as to how we are going to write our lines of codes. Right. Now we said there is a system that is followed for us to come up with these rules, and we are calling it the CFG, the context-free grammar. Okay. Now the context-free grammar is then highlighted. Okay. The notation that is followed is known as the Bocas norm. Okay. It's one of the major ways in which you can denote the CFG rules. Okay. So that there is a form of like a common notation when you're describing the rules that are going to be followed when you're writing your piece of code in a certain programming language. Okay. So now a small task for us right now, for those who are joining this late, is we are trying to see what BNF is. Okay. Also, try and recall what CFG was, and there are those 4 main tuples that describe CFG. So you can recall those and highlight something on the chart. That would be very good. I'll give you 2 minutes. Okay, and then we can continue. Good. I see someone has written something: variables, terminals, production, and a start variable. That is very true. That is very true. And in this case, actually, I'm going to talk more about productions in a short while. Okay? So I hope all of us have seen that, what Junior is writing there. So that is CFG, right? Very true, very true. BNF, on the other hand, what is BNF? Okay, so you see, I hope you can see these common terms that are coming up, right? When you check for BNF, you're seeing a notation, right? It's a notation for context-free grammar, right? So it's a standard way of trying to write CFG. Okay, I don't know whether you've checked on the history. Okay, was this a person who came up with this, or was it a committee that came up with this? Okay, those are some of the background information that is also important. It's also good to appreciate where certain things came from. Okay, so you can also check on that. Okay? I also recommend you also be typing something on the chat for everyone. Remember, our attendance is being marked by you participating in class, especially on the chat. If you're able to activate your mic, well, that is a bonus point. But try and exactly right. So I see Isaac has highlighted something invented by John Bacchus and Peter Noll. Okay, a while back. Okay, so it's just a common notation of you being able to describe these rules, the CFG rules. Okay, I hope you can see that. Right. Maybe some Good. Perfect. 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 I know I disappeared for a second. I was trying to switch my network. I think this is better. Good. Good. So yes. So I appreciate all the input that is being given. Okay. In the sense that if you're to look at it, we are predefining the rules of a certain programming language. Okay. So let's say I'm going to start with this example. Let me see who is here. The first person over here is Isaac. Yes. So let's say Isaac wants to come up with a programming language of his own. He wants to call it Isaac 2.0. Okay. For some reason, he's decided to call it Isaac 2.0. Okay. So what he needs to do first so that he can come up with this programming language so that later on it can be compiled by a certain compiler, the first thing he needs to do is that he needs to come up with a set of rules, okay, that are going to describe each and every aspect of that programming language. Okay. And with that in mind, you can see the complexity that is going to be involved here, because you are going to have to predefine everything. You're going to predefine what a statement is. Okay. For instance, you're going to have to define what an expression is. You're going to have to define what a term is, what a factor is. Okay. All the different aspects that you find in a programming language, you're going to have to define them. Even operators, you're going to have to define them. Okay. And I'm going to start by sharing something small over here. Okay. Let me show you. Let's start with this simple example, the one that I have here. Look at an example like this, okay? So this is an example of a programming language, and it's syntax, right? So the syntax in this case is just describing what an if statement is. Okay, a very simple example, right? I'm going to continue then elaborate further. Okay? So if you look at this one, we have an if statement over here that is being defined, and the if statement is being defined as an if, which is then followed by a condition. Okay, so this is a keyword followed by a condition, and then there is the word keyword then, okay, which is very important, and then after that there is a statement. After that, you can see there is this vertical bar. Now the vertical bar represents the different options of that syntax element. Okay, so in this case, the if statement can take three different options. It can take this option, the first one. Then after the vertical bar, this is another option that the if statement can take. Then after the vertical bar again, this is another option. So in this case, you have three different options. Okay. Now in this sense in CFG, right, this is what we tend to call as productions. Okay, so these vertical bars, the different options that we are having for this if statement are what we call productions. Okay, so if you remember, if you're looking at CFG, one of the main tuples that was found there was productions. Okay? So these are the productions that we have for the if statement in this case. There are three of them, right? So you can have an if statement following this structure, the first one, okay? And then after the vertical bar, this is another option, okay, where you can have the keyword if and then a condition, and then the then statement, a statement, and then after that you have and if. You can then also follow this notation. So what that means is, if you are writing a program in this language, okay, a generic one, I haven't given a name of which it is, right? You can either follow one of these three productions when you are writing an if statement. Is that okay up to there? Is that okay up to there? Yes, I even see Jaden has even given an example over there of something there. That is good. That is good. Let me go even further, and I think I'll start with an example now. Let me just stop the share. Let me highlight this. I have a series of pictures that I think are going to assist us. So just bear with me as I try to show them. Look at this one now. Look at this one. Look at this one. Look at this one. So now in this case, I'm giving an example. Okay? So based on what we have on the left, the different productions that I have on the left, okay, I said we are going to have different forms that the if statement can take for this specific programming language. I'm not saying for every, I'm just saying for this specific example that I'm giving. So there are three different productions that you can have. This is one, this is two, and this is three. So if I was to ask, so this example over here, I've taken a small snippet of a line of code. So out of the three, which one is being followed for this example that I've given on the right? As I try to consolidate everything that we have, so at least we can be on the same page. And try to engage, trying to engage. Don't be quiet. Try and say something, try and say something. It will make the class more lively and time will move faster. Good, perfect. So I hope you can see that this is the second one, right? So I hope you're seeing that in this case, okay, the person who wrote this program, let's say it was now Nicholas over there is the one who wrote this line of code. So he's asking if temperature is less or equals to 0, then he writes a description, it's freezing. And if, okay, so if you have to look at this left, okay, based on these rules that I have over here for the if statement for this programming language that we have designed, right? Okay, you see that the production that is being followed in this case, or the form for the if statement that is being followed is the second one. Okay? So in that case, what this means is you can follow this one, or you can follow the first one, or the last one. And I'm going to give you a chance right now. Okay, I may not be able to see it, but I want you to write a small if statement following the first option. Following the first option. If you are able to share it on the chat, that would be highly appreciated. Okay, I'll give you 1 or 2 minutes. Well, at least you can engage with this and try to see how, when you're writing your codes, right? When you're writing your pieces of code, right? Whatever language you're using, okay? This is the reason why you have to always follow the syntax, because the syntax is not something that is being built as you are writing the program. It's something that has been predefined, okay? It's predefined by a certain set of rules, okay? So I want you to write a small if statement following the first option, okay? And then later on, following the last option. Okay? Now, if you're going to share it on the chat, try and add maybe a description, maybe say this is option number 1, write that, and then option number 3, write this one, because I think I've already given an example of option number 2. Okay, so 1 or 2 minutes, 1 or 2 minutes, 1 or 2 minutes, and then I'll repeat. As you are doing that, I'll be repeating what we are doing, because I see some people are joining right now, and also we've experienced some very bad network conditions as we started the class. So yes, so for this class, we are trying to go into syntax analysis. And if you remember, before we had lexical analysis, where we broke down our lines of code into tokens. Okay? So we are now taking those tokens and we are trying to see whether those tokens are following the rules of a programming language. Okay? For whichever programming language you're having. Okay? So remember, a compiler will be designed for certain programming language. So in this case, we are talking about syntax analysis. Okay? And we are saying for syntax analysis to be done, it's done using some set of predefined rules. Okay? In essence, what we are saying is, if you've come up with your own programming language, let's say we are calling it Isaac 2.0, I'm giving just an example, right? You must define those rules beforehand, okay? And defining those rules means you have to describe each and every element that is going to be written in that programming language. We start by an example of an if statement, okay? So for this programming language that we are having here, okay, a generic one, we haven't said what the name is, right? We have 3 different options that the if statement can take. Okay, and we've gone even further and said that those options are called productions. Okay? So we can have one that is following the first scenario, where it's just an if keyword, and then we have a condition, then we have the keyword then, and then a statement. Then we can have the second option, which is given here on the right, okay, or we can have the last one. Okay, I saw a hand. I don't know whether you're okay. You just lowered it. Yes, say something.
Oh, I wanted to respond to that question, like via audio.
Okay. Which one?
Okay, so
oh, the one that I've given right now.
Yes.
Perfect. Go ahead.
Okay, so maybe in the first option, we can say an example of the first option is if grade is greater than 80, then the student has passed. The statement that should be put maybe is the student has passed. And then the third one is, for example, if grade is greater than 80, the student has passed, else print out the student should repeat the unit, then end if.
Perfect. Roseanne, I hope I've said the name right. Yes. Roseanne, yes. So that is correct, and I hope everyone has heard that. Okay, that's a good example and a point for you. Yes, so that is a very good example, and I see you can see this common structure in very many programming languages that are out there. I think C++ maybe follow this, maybe C. Okay, I don't want to say which one it is because I want to leave it in a generic way so that anyone who has that goal of coming up with their own programming language, they can see what they have to do. Okay, you have to predefine these elements. Okay. Let us go even further. I can see so many people have given so many examples. I appreciate those ones. Okay, that's how we are going to continuously engage. Let me open another example over here and show you how now we are going to go even further, okay, and define more elements in our programming language. Okay, in our programming language. So far, we've only defined an if statement. But remember, it's not only an if statement that has to be defined. You have to define all the different elements that are going to be found in that programming language. Yes, Waweru, I see you have your hand raised. Yes, say something.
Yeah, I have a question on. I can see that there's only one else. So what if you have other other options? Should you have other
Yes,
options?
yes.
So that
Actually,
it's else? Like if you have like
okay.
let's say three else's or more than that. So what do you do? Do you have to define all of them, or there's a way
Yes.
you can just shorten that process?
Okay. Allow me to respond that in a short while. I get what you're asking, but that's a good question. I don't know where he's gone to. I wanted to take his admission number. Just activate your mic again so that your name can pop up. Good. I want to take your number before we proceed. Good. Perfect. It's okay. You can lower your hand and mute. That's okay. Okay. Now, yes. So the question by Waweru is very important. Okay, because he's asking, right? So in this case, it's like we only consider in a situation where we only have two options for this if condition, right? So maybe one is A and then else. It just ends there. Okay. What you need to realize, and for everyone, this one goes for everyone, not just Waweru, is that when you're defining the rules for your programming language, okay, there is a sense of repetition. Okay. In fact, you'll find that there's a lot of redundancy. Okay. You have to predefine each and every aspect. Okay, so in this case, like Oweru is asking, right? So you need more else. You're considering a situation where maybe you're considering the grades, and the grades are more than one or more than two, because in this case we only have in two options, this one and this one. I think in this case, okay. So you have to predefine the if statement will have to go even further than that. Okay. Now, how do you define that even further? Maybe what you can do is the statement now, because you're also going to have to define what a statement is later on. You're going to see a statement. I'm going to highlight a statement, what a statement is in this programming language. You're going to predefine it and say maybe a statement can also constitute, right, a condition in it. Okay. So that may take care of what Waweru is asking. Okay. But in essence, yes, you'll have to predefine each and every item, okay, including the different options that you may have. Now, I challenge you, how can you predefine an if statement in such a way that it has infinite options? Okay? Because I don't want you to have a limit. Because you see, if we were to write over here, else, I don't know whether you see what I mean. Okay? Let me show you. Because Waweru has highlighted that. For instance, let's say we have if, and then we have something like a condition. Allow me just to use shorthand for a second. Then we have maybe something like a statement over here, and then we have else, right? And then, okay, that one is already highlighted. Maybe we can have else if. Let me even highlight that. Maybe something like that. Condition as well. Okay, so you can do this recursively all the way to the end, more and more and more and more. But then that seems inefficient. Okay, so what I'm asking is, do you think there is a way, right, that we can predefine our if condition so that it can take care of infinite options, so that you don't have to keep on predefining all of them all together? Okay. That is a question that I'm going to give you even a day or so to answer. Okay. And anybody who's going to find an answer, kindly contact me via email. I'll be able to give you a substantial amount of points there. Okay. But anyway, just to cut the story short and answer Waweru, yes, you have to predefine each and every aspect. Okay. So if only two are predefined here, it means in this programming language, if you put a condition or an if statement where there are more than two options, okay, the programming language will not recognize it. It will take it as a syntax error. Okay. So you have to predefine each and every aspect that you're talking about here. Okay. Anyway, I hope I've answered that question, Waweru. You can acknowledge that it has. But what I'm trying to show is, right, first, we started by only describing what an if statement was, okay, using three different sets of productions. Okay, so we had this first option, second option, and the third option. Okay, on top of that, you also have to predefine what a condition is. Okay, so in this programming language that I have here, right, a condition is said to be an expression, okay, followed by a relational operator, followed by an expression. Okay, on top of that, this programming language goes even further and defines what a relational operator is. It says a relational operator is one of these operators. Okay, so you can see here there are these vertical lines. The vertical lines represent the different productions, or the different, it represents the productions, which in simple terms are the different options for that element. So in this case, a relational operator can be a lesser than sign, it can be a greater sign, it can be less or equal sign, it can be greater or equal, okay, or finally it can be equal sign. Okay, so one of these in this programming language is a relational operator. Okay, on top of that, this programming language goes even further and defines what an expression is. Okay, and in this case, it's saying an expression, okay, can be made up of another expression plus a term, or another production, an expression minus a term, or just a term. So an expression can also be a term. It can either be these different productions over there. So I don't know that you're seeing the recursive nature of this definition. Okay, each and every item when it's defined at the top, right? Subsequently, later on, it's defined. A term, then, after we defined an expression and all that, we've then gone even further, right? Okay, we can go even further and define what a term is. We now say a term again can even constitute another term, right, being multiplied by a factor, or it can be a term divided by a factor, or it can be a factor itself. I don't know if you've seen that. We are going further and further and further in our definitions. After that, what is not defined? A factor. We then go ahead and define what a factor is. We say a factor in this case is an identifier, or a number, or an expression in parentheses. I want you to take a minute and just digest that information and see the amount of work that programmers do, right? Especially those who came up with the original compilers, right? They have to predefine each and every item. Okay? Not only the programmers who came up with the compilers, but the programmers also who came up with programming languages. For example, the person who came up with Python. Okay, I remember I was reading about him somewhere, and he was saying he didn't like the header files and all those things that used to be written there. Okay? So you can see when he was coming up with Python, he must have predefined all these items. So yes, I don't know that it was Isaac who asked this question the other time you were here, but if you want to come up with your own programming language, you'll have to come up with all these different elements. Okay, you'll have to give different productions for different items that are found in that programming language of yours. Let me go even further. In case you have a question, you can ask. You can ask. Let me just stop the share. I have another image that I want to open that I think will somewhat summarize everything now. Okay? Where is that? Where is that? Perfect. It's perfect. Okay. Look at that. Look at that. So now, okay, I remember we just started by defining what an if statement is for this programming language. I'm not saying for all of them. Okay, take note of that. This is very important. Don't make that mistake. I'm just saying for this specific language. I haven't even given what name this programming language is. I'm just calling it a generic programming language, right? So you see, even after defining a factor, we went even further and had to define what a statement is. Okay, and you can see that statements are even being defined as a statement, okay, combined with other statements. Okay, then we go even further and now define what a statement is. The first one was plural, right? Statements. So it was constituting of a statement and more statements. Then after that, we have to go further and define what a statement is. The reason why we are having this recursive, okay, this kind of a repetitive definition is because you're trying to take care of all the different options that may take place in this programming language. I hope that is clear up to now. So you see even further, we go even further when we talk about an assignment. Okay, an assignment in this case, I know in other languages you've seen that the assignment usually involves two equal signs. Okay, two of them. Now in this particular one, only one is used. Okay, only one is used. But I know there are certain programming languages. You can give an example. You can hear me. An example of a programming language where the assignment is usually two equal signs following each other. But for this specific one, right, an assignment is only using one equal sign. We go even further after defining what an assignment is. It involves an identifier, an equal sign, and an expression. We go even further and now define what an identifier is for this programming language. So for this programming language, we are saying an identifier will constitute a letter, or an identifier and a letter, or an identifier and a digit. After that, we even go even further and define what a letter is. What is a letter? You have to define each and every item that you're going to use in that programming language. So in this case, we ask ourselves, what is a letter? So a letter in this case will constitute the alphabets, I think, of the English language, A or B or C or D, right? So remember, the slash, the vertical line represents the different forms that that item can take, or what we are calling in short, productions. Okay. Then even a number is defined. What is a number? A number will constitute an integer or an integer and another integer. Oh, sorry, here there is a dot. So I think this one is supposed, I don't know whether yes. So this one should be, maybe we are considering a case where we have a decimal point. Okay. We then go even further and define what an integer is. So you can see all the way from here down, we are just defining the syntax or the rules of this programming language. We even have defined what quotes are at the end, characters, all that and all that and all that. A second to digest that. Okay? Because now I want to bring in the idea of compiling now. Okay, so we were talking about the rules which are predefined. So the question I know that you're asking yourself is, so how does this apply to what we are learning right now? How does this apply to compiler construction? Okay, how does this apply to compiler construction? If we are still together, say something. If you are still together, say something. Okay. Oh yes, Oweru, if you don't mind, can you try and summarize your question on the chat to avoid me repeating it all the time, because I see so many people are eager to remember what it was. Okay, but what you had asked is because the production that I have here for the if statement are only 3. Okay, and the last one seems to be the one that is giving more options. In this case, you only have a condition and then a statement and then end, right? But what Waweru was asking, take an instance where you have like the grading of students, right? So a grade can either be A, B, C, D, all the way maybe to F, right? Something like that. So he's asking, how can you take care of that using the production that you have here for the if statement, right? Now the question I'm asking is, right, do you have to predefine an instance where you'll have to have another production which talks about if, then, else if continuously, okay? Or do you think it's already covered even by the ones that are here? Or do you need another way? And it's an open-ended question. Yes, someone has a question. Or maybe a comment. Say something, someone.
All right, good morning.
Hello. I can't hear you that well. Just come closer to the mic.
Hello.
Yes, I can hear you now.
Okay. Does it mean then in our lab 1 we had to define all these productions in order to come up with a simple lexical analyzer?
Okay.
So that's my question.
Oh, come again. I think I didn't hear you well. I thought you are building up the question.
Oh, sorry.
Okay.
Okay, in our lab 1, when you're supposed to come up with a simple lexical analyzer.
Lexical analyzer, yes.
Yes. Does it mean then we have to come up with all these rules to
yes. By the way, don't yes, that's a good question by Samuel, by the way, because there's a tendency for people to confuse what you are doing, the regular expressions, right? The one that are defining certain languages, okay, with the syntax rules. Those are 2 different items, okay? Okay, those are not the same thing, okay? So the regular expressions, right? Those ones were just defining the tokenization process, right, of a certain language, so that you can check whether it abides by that language that you're talking about, right? So the syntax rules, on the other hand, are different. This is talking about the structure, okay, the structure. And by the way, I think I'll make things clearer when we go to my notes, Samuel. Okay, just give me a short while. I like to discuss something on the whiteboard and then I go to the notes. Okay, so in a short while I'll go to the notes. I'll transition to the notes, and you'll see the difference over there. I'll even highlight why the lexical regular expressions are not used to develop the rules. Okay, I'll explain that. I see another hand.
Hi.
Yes, how are you?
I'm good. How are you?
I'm good too.
Okay, so I wanted to try. I think the what Madenge was asking about
Okay.
if we have to define everything. I think it's already catered for. So, for example, if let's say we want to cater for, this is just my opinion. If we want to cater for something like an infinite number of conditions, can we do?
Okay.
Can we like let's say a loop and say while this number of if statements, then expand this already predefined if into, let's say, 5 conditions, something of the sort.
Let me take your number for the student ID. I think that's a very good way of looking at it. Or I don't know whether you are seeing what she's saying. Right? I'm challenging this to everyone because it's one of those things. Once your eyes opens to see it, right, it will be very easy to understand why the syntax rules are the way they are. Okay. I see another hand. People are getting ideas. Yes, say something as I give some points over here.
Okay, I just wanted to say that probably I'll like take you to the bottom part, yeah, the part for characters.
Yes.
And you can see there's a bit of recursion whereby it's character, then characters. So
Perfect.
you can find that you can have one character, and then when you define characters, it will be recursive. So can you do the same thing for the if statement, whereby you just
that
have
is the answer.
Statement condition.
Madenge, that's the answer. You don't even need to go further. That's the answer, Madenge. Okay. So in this case, that nature of having recursive definition of different elements helps you to have that infinite definition of a certain programming statement. Okay. So in this case, okay, sorry, I'll cut you short over there. But for instance, the if condition in this case, sorry, the if statement, not condition, the if statement, right? You see, we've defined what an if statement is by highlighting that it consists of conditions and a statement. So in your expressions over here, down here, okay, when you're defining what a condition is, right, remember the condition also will have a recursive definition. Okay, it will not only be a single thing, it will also have a recursive definition. It will define itself by having another expression, by having a relation operator and another expression. On top of that, we go even deeper and define what a statement is. You can see it's down here. Okay. And even better, if you have to look at this, Madenge and everyone, look at this one. I want you to take note of this one, especially this one that I'm circling over here. Take note of it. What can you see in there? Which is very important for us in this case, so that we can have an infinite definition of this thing over here, so that we can take care of any options that you may need. If we need 10 options, 20 different options, it's already taken care of here. Where can you see it? Can someone see what I'm looking for?
There's a for loop.
Yes, but even before that, even before that, this one here.
Statement in the statement.
Perfect. Okay, perfect. Now I don't know who I'm going to give a point there, but anyway, yes, there's an if statement. That one is the key that I'm looking for. Okay, because even after defining only a single if statement over here, right, it's already predefined here again. Okay, there's a recursive definition of it. Okay, so that means, right, this definition allows you to have like an infinite definition that will take care of different options that you'll have. So for instance, if you have options like 20 options, right, you can keep on calling for a statement. So each and every time a statement is invoked, right, you can include it as an if statement. Each time you describe a statement here, it can be taken as an if statement. Okay, so when the compiler now, and this is where I'm now trying to bring in where the compiler comes in. So when the compiler, okay, is compiling your programming code, your program code or your code, whatever you've written, right? Whenever it sees a statement and then it sees that that statement is then described as an if statement, it's going to take it as a legit code. But anyway, let me just stop the share here. Let me share something. The final thing. Let us bring everything together so that at least we are not in limbo and we are lost. Okay. So now, having those predefined roles that we've spoken about, okay, where you have to define each and every item. What your compiler does now, right? It uses those roles as a reference, okay, to analyze any line of code that you've given it. Okay. Let me share this. Okay. So whenever it's given a certain line of code, okay, what it does is, okay, it will analyze that line of code using the rules that you have. These rules, these predefined rules over here. So I'm not saying this is an exhaustive list. I'm just saying this is an example of one. Okay, there may be more than this or even less than this. Okay, depends on what language you've written for yourself, right? So the compiler now will make reference to this, okay, and it will break down the different tokens that you have. Remember that if statement that we had before, the if statement that we have, in this case now is derived into a parse tree. Okay, a parse tree. If you remember, we spoke about a parse tree in the first class. Okay, so it has been broken down into a parse tree. Okay, and it's made up of the different syntax elements that we have on the left. Okay, so we have the if statement, the one that had been written at the top, and then now we've broken it down all the way to the different elements that we have here, so that we can lead up to this. The ones that are circled in red are the actual line. They are the actual program line. Okay, so that is what the compiler does. So the compiler will break down whatever line of code you've given it. Okay, so A plus B, I'm just giving an example, plus C. Okay, so it will break down this line into a parse tree using these rules. Now, if there is any error somewhere in terms of it's not following any of these rules, then you are given a syntax error. I hope that, in a way, in a nutshell, gives you a very broad spectrum of what we are going to talk about in this class when we are talking about syntax analysis. Okay? And I'm going to leave that image there for a minute as I see whether there's someone who's going to ask a question or maybe a comment. before we proceed now to the notes. I think we have a very good overview. Even better. So, Makale, if you don't mind, just copy paste that to everyone. So he has a very good question over here. Okay, and someone is asking here. So for a certain specific language, okay, where is the compiler getting these syntax rules? Okay, so do you think they will have to be contained within the compiler itself? I think I've already answered that question in a way, but what do you think? I think I can pose that to everyone. So where is it getting all these rules? Okay. Do you think compilers are usually connected with a database, or they already have that database in quotes within them? I think that's the question that Makale is asking in this case, because he's wondering. So right now I've written a program, I've already written my if statements, I've written my statements, everything, and I want to compile them, and my compiler is over here working overtime to try and compile my code. So where does it get these rules? We've said they're already predefined. So does it call upon a certain file? Does it call upon a certain folder? Or are these rules already contained within it? Okay, I think that is the better question in this case. Okay, so 1 minute as I switch to my notes. Okay. So I think the simpler answer, and the most kind of like generic answer to have in this case is just to say that these rules already be contained in the compiler. Okay, the specifics about it. Okay, the specifics about it is something that you're going to find with time. Okay, but then I challenge you, Makale, I think that's the name. Yes, Makale. Just try and read ahead and tell me, where do you think they are found? But yes, the answer is they are contained within the compiler itself. Okay. Do you remember things? There's something that I mentioned when we were starting in the first class, and I talked about something called a symbol table. Maybe that one can lead you in the right direction. Just a small hint. I like when people make self-discovery. Self-discovery is always better because you'll always remember what you found. I hope you can see my notes. This is where we are. Take note, I'm going to repeat some items that I've already spoken about, because what we just had in that first small session, okay, in that small section, okay, was just a preamble of what we are going to discuss. I see so many questions popping up. Even some people are talking about the ambiguity in parse tree. Yes, we are headed there. Hold your horses. It's good to see that people have read ahead. I like this. Allow me to sip some water. So let me give us a short break for 2 minutes, and then I come back, and then I can officially start with my notes. But if you have more questions, don't hesitate, ask them. Good. I'm thinking I cover a few slides, then I can give us an official break instead of having small breaks all the time. So syntax analysis. Now, based on what I've said within those few minutes since we started, what do you think syntax analysis is in this case now? Okay. What is it? I would like to hear your views as I start going through the notes. Okay. What do you think it is? You can say something on the chat, right? And I'm going to start by just referencing in my notes what we did in the previous class, right? So where we mentioned scanning, right? So scanning was just that process where we were able to take our lines of codes and break down into the small streams of words, okay, or what we are calling tokens, okay? And then after that, right, now the PESA, okay, which is our syntax analyzer, right, will take now those tokens and try to see whether they meet the rules that are predefined by that programming language. Okay. Also here, I'm also going ahead and talking about what the front end also involve. It also involve the semantic analysis. Okay. Now semantics is all about the meaning, right? So first we check the rules and see that the rules are okay, but also we need to check the meaning, right? So for example, the example that I gave up there, we were talking about a cow jumping over a bus, maybe it may not make sense in terms of the meaning, but then the syntax is okay. Okay. Then after that, after we've done syntax analysis and the semantic analysis, we'll then have an intermediate representation of the source program, which then is then fed to the back end, which then produces our target code. Okay, good. So I think we already did this, but it doesn't hurt to repeat for maybe people who joined in late. You can see we started by just defining a common sentence in the English language, okay? And we broke it down into the different elements that make up the English grammar, right? So things like nouns, things like verbs, okay? Things like objects and all that, okay? And we said that one of the rules that is followed when you're writing a sentence in the English language is where you have this structure being followed, where you have a subject, you have a verb that is an action, and then finally you have an object, okay? So when you have those three items, you have a complete sentence. Okay, that is one example, right? So that is a production for the English language, if you want it to be said better. Okay, so we said using the same analogy, we can borrow that and apply it in programming language. Okay, and the best example that we found here was us starting by an if statement. Okay, where we broke down an if statement, okay, into the different components that make up that statement. So for example, the one that I have here on the right, we have an if statement that consists of a Boolean expression and some form of assignments. Okay, so these are assignments, these are an assignment, these are another assignments over here, these two. Okay. Then you have these one over here. So for instance, maybe that is these all together, this is the condition. Okay, and maybe this is also another condition, okay, something like that, or maybe a statement. Okay, it's open to interpretation depending on how you want to look at it. Okay? So yes, so I can see so many people coming up with so many ideas of what the syntax analysis is, but in simple terms, I can just say this: the syntax analysis in this case is, okay, we are just going through our entire tokenized lines of code, and you're trying to see whether they adhere to the rules of that programming language. Okay, now these rules are already predefined. So yes, the statement, yeah. So look at that. I want you to look at that even before about it. Look at this. Do you think there are errors here? Okay, and by looking at it, which language do you think this is? Is it C or C++? Okay, just take your time and then let me know. Okay. Because you see what we are trying to say here is that the syntax analysis, or the PESA in this case, the syntax analyzer or the PESA, what it's trying to do is it's trying to check whether our program abides with the syntax of that language. Okay. Now, if you have to look here, you'll see that there are several errors that are there. Okay. Number one, if you have to look at it, I don't know that you can see brackets. We call it parentheses, right? So some are not correctly placed. On top of that, the semicolons, there should be a semicolon somewhere that you can see it there, or it's absent. It's a question that I'm asking that I will then answer slide. Okay. Okay. I then go even further over here and a question that has just been asked right now about the relation between regular expression and what our PESA is doing. Okay. And we are saying that if you have to look at this example of line of codes that I have over here, okay, it's clear to see that if you are to follow a regular expression, kind of rules. Okay, we are to use the regular expressions and the rules that we are following for defining regular expression, be able to identify those errors that I'm mentioning. For instance, the one that I've given here is the one for brackets, right? Parentheses, right? Okay, you'll not be able to find them. Why? If you remember your regular expression and when being used, okay, there were certain things that were being okay, and also because of the notation that is used in regular expressions. Okay. Are we together? People are going to be silent. We are still together. We are lost. We are still lost. Apologies for that. I don't know what is happening today. Anybody who is following, where were we cut off? What was I discussing before? I was rudely interrupted. You can hear me? Acknowledge. I don't know what is happening.
I can hear you.
Good. Okay. So I was just describing the syntax analysis process, right? And I just taken a small, some lines of codes over here, right? And I was just trying to identify some errors that are found in these lines of codes, okay? Okay. And I even went even further in the next slide, and I was talking about this programming language, in this case being C++, okay? So now at least your mind can settle and remember some of the syntax rules that are followed when you're applying C++, right? And so if you have to look at it, you can see some of the errors that are here, right? So in line 1, you can see the parentheses at the end, right? There are 2 of them instead of being 1, okay? The Boolean expression in loop, right? In line 3 over here, I don't know that you can see it, right? I and J, there is a missing assignment over there. We don't know what is happening there. We just say K is equals to 0, then what? We don't say. Then line 4, there's a missing semicolon, okay? So all those errors in this case are because the person who wrote these lines of code did not follow the syntax. The syntax for C++. So while the compiler now is running through this, okay, when it was breaking it down into the different lexemes so that they can be converted into tokens, chances are it did not notice some of these errors, okay, because those rules are not predefined within regular expressions, right? So regular expression just define maybe in terms of the symbols and all that, right? It doesn't define that when certain thing comes, then something else has to come afterwards, right? There are no those elaborate definitions, okay? So that is not defined within regular expressions themselves. So that's the reason why we need the pacer, okay? We need an extra step, okay? The one that has these rules, okay, these production rules predefined within it. Okay? I hope that makes sense up to now. I hope that makes sense up to now. So there's someone who asked a question earlier, and they asked that when you are talking about lexical analysis, right, we spoke about regular expressions, okay? And in regular expressions, there seem to be a set of rules that are being followed there, right? You remember the 4 rules that we had? I think actually there were 5, right? 5 rules, right? And he asked, if we have those rules, do we have them to define other rules for the syntax? Okay, and the answer that I gave, a simple answer, was yes. Okay, now here we've seen an example where some of the syntax rules are not being followed. Okay, but then if I was to ask you to break down this into the different tokens that are there, you'd actually be able to break it down into the different tokens that are there. You'd be able to break it down into something like 4. For instance, 4 may be taken as one string, okay, in this programming language. K may, on the other hand, be taken as just the alphabet, the way it is in terms of the regular expressions. Okay. However, when you come to the syntax rules, right, you find that the rules go even further by defining each element and what it's made up of. So, for instance, for a for loop, okay, there are certain rules that are followed, even when you're talking about C++ language, right? So a for loop, what does a for loop have in a C++ programming language? Okay? What are some of the elements, some of the notable elements that are there? Just to see whether we are together. Hello, are we there? Or even simpler, an if statement. Let's start with an if statement. Maybe a for loop is a bit complicated. An if statement in C++, object-oriented programming, or even Java, if then that is better. Okay. If you're talking about a condition, what are some of the items that stand out? I know most of us are right now headed to Google to try and see some of those items. Okay. Anyone? Anyway. So some of those items. Oh, yes, Gitao, good.
For a for loop, you have a start index, then a condition, and then an increment or decrement.
Perfect.
And then for an if statement, you just have a condition, like, it could be an expression as well that results in a Boolean condition, basically.
Perfect. I agree with that. So look at it in that light. Okay. If you are looking at the regular expressions that we had earlier, right? They did not predefine some of those items, the ones that Gitao has just described over there. So you can see if you are relying on the regular expression or the lexical analyzer, okay, you will not be able to catch some of these syntax errors that are going to be found in that lines of codes. Okay. In essence, right, the syntax rules are a bit more complicated as compared to the ones that we found in the lexical analysis, right? For syntax, you need database so that you can consider all the different productions that you're going to have. Okay. So that's the reason why if you have to ask yourself why the regular expressions that were involved before cannot hold the rules that have been applied for syntax analysis. It's because of that. Okay. Anyway, so I then highlight a different problem here. So if you have to look at these lines of code using the same programming language, C++, is the syntax okay? Anyone? Or maybe I can place even the other one. Let me bring the other one. So this was before where we found there were some syntax errors. I want you to compare it with this one now. Let me bring it here. So look at these two. So this one, we already highlighted that there were syntax errors. You can see the parentheses over there. The Boolean expression over here is not well defined. Okay. Also, there should be a semicolon here after the for loop. Okay. But then, okay. So if you have to look at this second one, right? The syntax is okay. However, let me just delete this. However, the semantics, right? The meaning behind it is not okay. Okay. Why? Because of this. The local variable sum has not been declared. Okay. So you see there's sum here. We are talking about it, but then there is no declaration of it up here. Okay. So if we are doing syntax analysis, this right here may pass through. If we are only doing syntax analysis up to now. Okay, it will pass. Okay, it will pass. But then when it comes to the semantic later on, okay, it will not be found. Yes, Gitao, I think I missed the semicolon. Yes. So notwithstanding the semicolon, let me try to see whether I can get the intonation. Sorry, where is my intonation? Let me see. Can I be able to make an intonation? Okay, I am not able to make an intonation here. I don't know why. Okay, but yes. So if we are doing syntax analysis only, right? Notwithstanding the semicolon that appears after the for loop, right? Then this line of code will be able to pass. But then when it goes to the semantics analysis, right? That's where the error will be able to pop up. Okay, and in this case, I'm referring to this example over here in the English language. Okay, where I'm saying a statement like this: he wrote the computer. Okay, so in terms of the syntax, there is no error there, right? Because as you can see, we have a subject, we have an action, a verb, and then finally we have an object. However, I don't think people write computers, do they? They don't write. So the meaning behind it does not make sense. Okay? Not unless you say the computer, maybe it's a name that stands for something. Okay, so we don't know the context. But even if we don't have the context the way it is in a generic way, right? This statement over here is seen. The syntax is correct, but then the semantic does not make sense. Okay? I saw a hand being raised. You can ask a question. or maybe you have answered even before we go there. Okay, I don't see.
Yeah, it was answered.
Oh, you have answered. Okay, perfect. So we have that. Anyway, so to bring things together, okay, I know this is a question that everyone has in their mind. So what is the role of the pacer? Okay, what is the role of the pacer? And we are saying that not all sequences of tokens are programs. Okay, so your pacer, okay, or your syntax analyzer has to distinguish between valid and invalid sequences of tokens. So we've already taken the tokens that we found using our lexical analyzer. Okay, now our pacer has to identify between valid and invalid sequences of tokens. Okay, those are the ones that are following the rules and those ones that are not following the rules. Okay, the pacer also, okay, uses a similar mechanism to the one that we were using before, where we were calling an acceptor, where the acceptor was then based on what we were calling automatas, right? So in this case also, the pacer will also follow a certain acceptor mechanism, okay, to check whether the tokens that have been given to it, okay, are following those rules. Okay, so it's a similar kind of a structure, but now in this case, this acceptor, okay, will be more detailed in terms of the rules that it will have. Okay. Now the process at which we are going to discover whether these tokens are satisfying those syntax rules is what we call derivation. Okay, so it's like we are trying to derive a certain language and its certain expressions or in certain statements or conditions, whatever they are. Okay? So that process of discovering, okay, those tokens and how they are made up, okay, is what we are going to do when we say we are deriving a certain language. The different tokens based on a certain language is what is now known as parsing. Okay, because you're just trying to break down the different tokens that you've been given, okay, into that pastry, okay, constituting the different syntax elements that you have. Okay, obviously here by a grammar G, okay, can be indicated as LG, okay, and now, okay, that language can be represented using what we call the context-free grammar, which we said is a system that is used to represent these roles. However, the notation now, the one that is used to represent the CFG, is what we call the BNF, Backus No Form. Okay? I wish to have a break now, an official break, around 10 or so minutes. Now that at least we have something in mind, then when we come back, we can just talk about pastry, CFG, and maybe try and do one derivation. Then we can continue from there. In case you have a question, don't hesitate to ask. So 10 minutes, and then we can come back at 10:46. I thought to be able to complete everything, but unfortunately will not be able. I think I'm going to request for makeup next week. Not this week. This week I know you have a lot of work. You even have a CAT to cover. So because of the class that we missed last week, I'll request for 1 hour next week. Okay, so maybe you guys can discuss and can agree. I only need 1 hour next week on top of the class that we'll have on Tuesday, so that you're able to catch up. I don't like having makeups towards the end of the course, because at that time, that's when everybody is looking for makeup classes if they missed any. So I prefer to do mine a bit earlier so that we have a lot of time towards the end. So you guys can discuss and let me know. Anyway, I don't think we'll be able to cover everything I had planned for today. I want just to prioritize on what I can, and then I can leave you guys to do a bit of lab and some CAT here and there. So yes, I just want to make a small reference to CFG. Okay, the context-free grammar. And like we said, there are the 4 tuple items that define a context-free grammar, right? There will always be a start symbol, a set of non-terminals, node symbols, non-terminals, a set of terminals, and then a set of productions. I think by now we've encountered the productions in the sense that it's the different options that you have for a certain element. Okay, and because of the question that was asked, I found it important to mention this and highlight them in the slides. You'll find them, and we're asking why aren't regular expressions used to represent the syntax? Okay? Because I think the person who asked that question earlier probably was thinking, okay, so why do we have to do these double representations that we have? Why can't we just use the regular expressions to even cover syntax analysis, right? Killing 2 birds with 1 stone, right? But the answer, and I think you can find it here, is because our regular expressions do not have enough power. Even the storage, they cannot be able to have enough power to cover all the syntax rules that are there for programming language. Okay, using those examples that I was given earlier when we were starting the class, you saw how the regular expressions. Okay. Also, if you remember this in your automata theory, okay, you'll see this, that a finite automaton cannot remember the number of times it has visited a particular state. Okay. So why do you think that is a disadvantage when it comes to syntax analysis? The fact that a finite automaton cannot remember the number of times it has visited a particular state. Okay. So if it has gone through, for instance, a certain state 1 twice, it's a loop, right? It can't remember how many times it was there, right? It's like one of those animals. I think they are warthogs. Whenever you hit them, they forget immediately, and then they come back and you hit them again. Okay? So why do you think that is a drawback when you're trying to define syntax rules? Okay, exactly, right? So one, you might even create infinite loops within a certain language, okay, which will lead to more errors. Yeah. So I agree with that, Papa. I wish you had said that with the mic. That would have been a point for you. But that is true. Okay, you will have to create infinite loops. Okay, which is a very big problem in this case. Okay. Anyway, I want to elaborate a bit further on CFG so that you can see now how the Pacer, okay, our syntax analyzer, is going to break down our lines of codes. Okay. Now, I want us to start with this example. Look at this production that I have over here of, I can't stretch it. But anyway, so we have ship noise. Okay, I'm just giving a general example, ship noise. And in this case, a ship noise is defined as a ship noise plus the word bar, and then, or it can just constitute the word bar itself. Okay? So using that, we can come up with this line of bar of how a ship makes the noise, right? Because in this case, you can see here, we are following these rules up here. Okay, well, we started the ship noise. Okay, we then went ahead and said the ship noise can also constitute a ship noise and bar. So we went ahead and started with the first one, the first production alone, and then we went even further by replacing the ship noise now, right, with the bar again, the second one now, the second production, and then finally we went ahead and replaced the entire ship noise now to only include the words bar, bar, bar. Now, I know that is not technically it's not giving you that fulfillment that you need. This is the reason why we need to go to more technical items by looking at a programming language. And let me go there even further so that you can see that. Consider this other production that I have over here of what an expression is. Okay? So in this case, I don't know whether I need to go to the whiteboard, but I think I can write here. So in this case, I'm saying an expression. If you're not able to see it well, we are starting by defining what an expression is. Okay, we've started by saying what an expression is, and we are asking, that's the question, right? So an expression in this case is being said to be an expression. I'm just going to write the first one, and an operator and an expression. Okay, we then go further and break it down that this expression can either be an expression and operator and an expression, or this is where the under production is. Okay, the vertical line. I don't know if I can. Yes, there's a vertical line. Okay, so an expression can also be a number, or it can also be an identifier. Or okay, I hope you can see that. Then after that, we go next, and then we now defined what an operator is. I hope you're seeing that, right? So that is what we are defining some small rules over here, okay, for a certain programming language. And we are saying an operator in this case can be a plus sign, right? Or I hope you're seeing this together with me. It can be minus, right? The subtraction sign. Or what else can it be? multiplication, right? Or it can be the division. Okay? So those are the rules that we have. Okay, so I'm giving here a bit of a background where I'm saying that some of the grammar rules that are used today, especially for C and C++, are heavily derived from this programming language called Algo 60. I don't know whether you've met it before when you are discussing about the history of programming languages or even history of computers. Okay? So most of what we find today, or so many programming languages, you'll find that the grammar that is used, the CFG that is used, was heavily borrowed from this. Okay, it's one of the maybe the first generation of programming languages that were out there, especially high-level programming languages, and it's also based on this notation of BNF, the Backus-Naur form. Okay, now I want us to use this set of rules, right, to derive a simple line. Okay, now that I've already elaborated that, I think the one that I have here maybe was not very visible, but I hope you have this in mind. This is what it means. So an expression is defined as this or this or this. An operator is then defined as this, this or this. Okay. So let's go to the next slide and we can try and derive a small sentence over here. And let me pick it and then I can bring it to the other side. Okay. So using the rules that I have, I can't be able to expression, operate expression, all that, I can derive this statement, okay, recursively until I have the individual elements. Okay, so first I can start by saying, okay, let me take my notation, take my text there. Okay, I can start by saying x minus 2 multiplied by y. So that is the statement. Okay, there is no. So from there, I can start by defining it using the first derivation rule that I have over here and say that this is constituting of an expression, okay, an operator, and another expression. Okay, I can go even further by replacing one of the expressions up here. Okay, one of the expression. Now in this case, I'm going to replace the first one over here because remember, I can either go and say that these ones are this expression, this operator, and then these final ones, these two, another expression. Or another way I can do it is to say that these two will be one expression, and then this final one will be another expression. Now, the way I've just designated those two different options will be the grounds of defining some of the derivation types that we have in this particular context, right? There is what we call leftmost derivation and rightmost derivation. Okay. So anyway, let's start with the first one where we are considering the last two to be one expression together, and then this one, x, to be an expression on itself. And then the operator, the one that is being defined here, is this minus sign over here. Okay. So in this case, I've defined that this is an expression, an operator, and an expression. So up there it's very generic, but then down here, I'm then going to go ahead and say, okay, that now the first expression now over there, I'll replace it by having now the definitive item over here. In this case, I'm going to say it's an identifier, right? A token type, and the word itself, which is x. Okay, so I'm just following the rules that are up there for this CFG, and then I'm going to have the operator and then the expression. Okay, then I'm going to go further, and then in this case, I'm going to repeat the same thing, ID x, right? And then I'm going to have now replace the operator now. Instead of having just the generic term operator, I'm going to put the minus. Okay, I'm just going to replace, and then I'm going to have the expression now. And then I can say ID, although that is a bit redundant, there was no need to do that. But anyway, ID x, and then here I'm going to have minus, and then the expression now again. Remember how it was defined? It was defined as an expression, okay, an operator, and an expression. So you can see I'm just using the recursive definition to break it down to the small finite elements of that syntax rules. So I'm going to go even further now and have this as ID x, okay, and then subtraction. And then in this case now, I'm going to replace the first expression, this one first here, this first one here. And in this case, it's constituting of, okay, a number, right? A number, which is 2. Okay. Then I'm going to put it there. And then I'm going to say an operator, and then expression. Okay. Then next, I'm going to go again further and have ID x. Okay. And then I'm going to have minus, the number. Okay. Now this is 2. And now instead of having now the generic expression, now I'm going to put the actual expression in this case. Maybe I can put this. There it is. And then I'm going to have expression. Okay, so I'm just breaking it down into the finite elements. Then I'm going to go to next, ID x, then I'm going to have minus number 2 that way. And now in this case, now I'm going to replace the final expression now, which now is just an identifier. Sorry, that was asterisk. It is now in this case just an identifier and y. Simple as that. Okay. So now using this CFG over here, okay, now for instance, your compiler will already have this CFG within it, right? It's able to break down this line of code, right, into the finite syntax element until to the end. So using that process, it's able to derive the CFG elements that are contained within that line of code. I don't know whether that makes sense the way it is up there. Okay, I want you to try the different option now. Okay, so here we started by this being together. Okay, I know I didn't put the brackets, but it's like we had done this when we started. Okay, it's like these were together that way. So that's how we were able to break it down. Essentially, what we did is we were replacing the leftmost non-terminal item. Okay, so that is what we are doing. So we started by replacing x, then we went further, we replaced the operator, then after that we went and broke down this expression, and then after this expression again we started by replacing only 2, then we went further and replaced only the operator, then after that we replaced y. Now try the reverse. I want you to see whether you can be able to come up with the reverse, right? It's x now, x to y, okay, but now in this case, okay, let this be one expression, okay, and this that way. So in that case, what that means is you're going to be replacing from the right. Okay, so start by replacing from the right. So start by replacing first y. So it's just going to be this, the mirror version of this, the mirror version of this. Okay. Good. I don't see any question. Now I may not be able to ask you to share your screen, all of us, because I know it will be a lot to do. So be honest with yourself. If there's somewhere you see like you're getting lost, just ask. Okay, because by understanding at least how the derivation is done, okay, you are able to understand how pacing is done. Okay, because in this case we are just replacing one of those items. Let me just get rid of the brackets because the brackets are not usually there. If you put the brackets, it highlights a sense of precedence, and actually that is one of the things that you're going to find, that when passing, we don't usually have any form of precedence, especially the one that we're used to in arithmetic. Okay, as you're going to see, with both leftmost and rightmost derivation, precedence is not often followed. By precedence, I mean that idea of BODMAS. I don't know whether you remember it, right? Where something like multiplication comes before subtraction, right? It's something that you'll find is not often followed. So in that case, you may have to define more rules so that you can have a sense of precedence in a certain programming language. Okay. I also remember someone was asking about ambiguity, right? So you'll find that in a certain expression like the one that I've just given here, this, not an expression, sorry, in a line of code like this one, right? You can have two different types of derivation. You can have this one or the one that I've asked you to try and come up with. So what happens in that case? You don't have that ambiguity to be there. So what you'll do is that you'll have to define more rules by maybe stating that something has to be derived first vis-a-vis another. Okay? I don't know who asked that question. Let me see whether I can remember and see. Let me go up the chart. Oh, did I lose that? Okay. Whoever it was, I hope I've given a small hint before we get there. Okay. What do we do? What do we do when we have ambiguity? Or maybe there are some who don't understand what we are talking about. Don't worry, we'll get there, whether today or in the coming class. Yes, Samuel.
I was the one who asked that question.
Oh, you're the one who asked. Perfect. Samuel. Yes. So Samuel is the one who had asked about ambiguity. Yes. So what happens there? Okay, we are going to see that. Don't feel as if you are lost. It's like we covered a concept that you never understood. Okay, so we are going to cover that. Okay, let us just take our time. Anyway, let me see whether I can find the answers as you're doing that. Allow me to stop the share for a second because I want to show you both rightmost derivation and rightmost derivation. I don't know whether I still have the state. Yeah, I have it. Okay. That is it. And do I have the rightmost? Yes. Okay. Yeah. Okay. So let me ask, if we are all together, which derivation do you think that one is? Okay. So the one that I did earlier, the one that I've done together with you guys, that was leftmost derivation. So is it this one? Okay. Do you think it's the one? Where you can see that we have, this is the goal that we have. Okay. And we are using the CFG that was there. Okay. So there is a tendency for people to wonder, how did this derivation come about, right? So remember, this derivation is being done following a certain CFG. So there are certain rules that are there. So it doesn't just appear from anywhere. I remember I gave those rules up there. Very two simple rules, two of them. Okay? Actually, they were just two productions of the same item of an expression. So I just gave a CFG for an expression, and I said an expression can either be something, something. I then went even further, defined what another expression can be. Using that, we're able to derive this. Okay? So yes, so if you are to look, this is leftmost derivation. Okay, let me share now the rightmost, the one that you guys were supposed to do, and check whether yours aligns with this one. Where is that? Where is that? Oh, have I lost it? I seem to have lost it. Just give me a second as I try to trace it. Where are you? Yeah, I seem to have lost it. I think I went. Nope. Okay. Let me just open the last one. CFG. Yes. That's the one. Perfect. So now we can share this one. Yep. So there it is. See now in rightmost derivation, if you are keen, you will see that the right hand side is the one that is. That's where we are starting to define. Everything is defined first, and then the left. That's where we have more expressions, right? Expression. So we started by replacing the rightmost expression, and then we found it. Then we went even further by defining this one. We went after that. We said that this is this, and then we have this all together. Then after that, we went further. We took now this one and broke it down to its finite elements, and then after that, we went now to the next. Okay, so we are starting from the right, going to the left. The other one, we are starting from the left, going to the right. Make sense up to there? I'd like to hear someone say something, acknowledge something on the chat before I proceed on the notes. Good. Makes a lot of sense. You can see how just following some simple rules. There are no complicated stuff. So that is what you're doing. Okay, I think I've already shown you. So yes. Okay, that is what you are doing. Okay, then rightmost, you are replacing the rightmost non-terminal at each step. Okay. Yes, I see a question. Please ask. I see a hand. I think it's Stacy.
Yes, I had a question.
Yes.
I was comparing the leftmost derivation and rightmost derivation.
Yes.
And I was just seeing how to do it in future, and I've noticed there's some difference. Could you share again? I explained.
Okay. So the difference is, let me just do this. Let me open a new slide, and then let me just stop.
Oh, I understood. I understood the concept.
Oh yes, I know you're saying the final result is always the same. It's in terms of the order of derivation. That's where the difference is coming.
Yes.
And especially when we are designing the pass tree, you'll see the difference. But I get the question. Let me just post them in a way that will show maybe a bit of a difference between them. Don't worry, that's a good question. Let me do that. Just give me a second. I had them as individual images because I just took a snap somewhere. There we go, and then the second one. Here we go. And maybe the emphasis that we need to put here is that the order at which we are deriving is the one that is somehow showing the difference between the two. Yes, perfect. Now I think I can share this. There we go. There. I hope that one is, oh, I didn't. So this one is the leftmost, this is the rightmost derivation. I don't know whether you can see some form of difference somewhere.
Yes.
You can see now, right?
I understand the concept. My main question was,
yes.
You see, when we're looking at the leftmost derivation, we start breaking down from the leftmost side.
Yes.
But you see here on the third line,
yes,
we expanded the expression on the right side. Because you see there's expression, operation, expression, operation, operator, expression.
Let me take my antonator. So you're saying on the third line here, okay? So we went that way, but then after this one, we went to the operator, which is the one we replaced. After that, we went to the expression.
Oh, no, I mean the third line.
This one here?
The one above it.
Okay, this one.
Yes.
Okay.
I can see so, there we began breaking down like the right side of the expression.
Okay. So what we did, I think these are different way at looking at it, because I think what I had done is immediately after this step, right? I did not have this step, right? I immediately just came to this one. I think this one will be better. But anyway, so what we're trying to do is look at this: x plus 2, this. Okay. So each constituent item without the operator, right, was taken as an expression. Okay, so they just defined this as an expression, this as an expression, and this as an expression. Okay, but then I see where the confusion would be. Yes, if I was the one, I think I would skip this step, because this step could be a bit confusing. Stacey, I don't know whether that helps.
Yes, right? Yes, it's just that I was looking at leftmost derivation, and we didn't include that, like coming from the right. Okay. Looking at the rightmost derivation, we didn't do the same thing, like in that context. So that's what I was asking about. Yeah.
Okay. That's a good question. And I think I hope that one has helped someone else out there, right, to see that. Anyway, can I show you the tree? Let me show you the tree. I think maybe the tree will make things a bit better. In case, let me first give some points where they are due. Good. There. So look at this. Let me just delete the annotations. Okay. So using the derivation that we did, right? I don't know whether you remember. So the goal was up here. The goal is obviously x minus 2 multiplied. So I think this one was multiplied y that way. Right. So you can see when you're looking at the evaluation order for leftmost, the same statement for the same line of code. Okay. For the leftmost, it's like we put brackets between 2 multiplied by y. Okay, because we were replacing from the left. Okay, so that's the reason why we had an expression, and then the first expression was just reduced immediately to the identifier x, and then next we replaced the operator. After that, we then went to the right hand side and we replaced now this entire one as an entire expression, these two. Okay, now that was done differently when we went to the rightmost derivation, because in this case, right, y was considered as if it was alone. Okay, it's like we, I don't know whether you can see now that difference over there, right? And in a way, you can see even the tree, how it's augmented. The one for the leftmost derivation, it's like heading to the right, and the one for the rightmost derivation, it's headed to the left. Okay, so don't get confused by those ones. All you need to remember is that for leftmost derivation, right, we are replacing the leftmost non-terminal symbol. We keep on replacing from the left. For rightmost, we keep replacing from the right. Okay? We have that. Okay. Let me clear this. Let me go ahead. I want to finalize something small. Bear with me. And I wanted to mention this term over here. Okay. The idea that in those two different derivations that we have over there, the precedence is not followed. Okay. It's not always followed. In some cases, there may be a case where it's followed. Okay. You may find an instance where maybe the precedence there, especially this one, the one that I'm following about, the arithmetic rules, where maybe something like multiplication has a higher precedence over something like subtraction. Okay? These are very common questions you'll even find on social media, right? Where people are given a question and then people are just debating, is the answer 16 or 1, or is it 9, or is it 0? Something like that, right? The trick there is usually the precedence of operations, right? So you'll find that in most cases, the parse tree, okay, the most parse tree that you have over here, when you're doing that derivation, the sense of precedence is not usually there. Okay, whether you use the leftmost derivation or the rightmost derivation, it's not always contained. Okay, so what we say is to create or to add a form of precedence, right? We have to create an non-terminal for each level of precedence. Okay. Or even before I go to the answer, I know I've given the answer, but let me ask you this. Okay? Let's come back here. Okay? If we had our statement, let me write our statement again. We have x. I think it was -2. If it's not, we'll just use that. Okay. So if you wanted to have precedence, what will you do so that someone can get the correct answer? It's a very simple thing to do. I have already even done it so many times. It's already even been done in this slide. But if I was to ask you, how would you ensure that there is precedence within this small line where x -2 multiplied by y? How would you enforce precedence so that multiplication is done first before subtraction? Yes, Caesar.
Can you say you put brackets?
I don't know whether anyone else is seeing that. I know it was very obvious, but I just needed to mention it. Even though it's obvious, it's very important to mention it. Okay? So in essence, that is what you need to do. Okay, you may need to enforce brackets, okay, within your rules. Okay, and the only way to enforce those rules when it comes to what is it called? When it comes to CFG, because we are not going to have brackets, right, is to create an terminal at each level of precedence. Okay? So you'll have to redefine the rules again now. So you see, previously we only had these rules over here. Where are they? These ones, right? So we only had these simple rules over here, right? So now we are redefining now the rules again so that we can have this. Okay, where an expression now in this case is not only defined as an expression plus an expression, it's also now be defined by a term. Okay, there is the inclusion of a term now. Okay, by having this element of a term, right, it helps to enforce that precedence within it. Okay. Now here's the thing, right? I remember when I learned this concept first, right? It was a bit vague and a bit abstract. Okay, but I want to challenge you, okay? Because I know our time is almost up. I just want to spend 2 more minutes explaining something. Okay, I want to challenge you. Just take these rules that I have here. I'll attach this notes on the e-learning, right? Just take this and then compare it with this. I don't know whether I can take that for you, but then I'll be able to change. I want you to compare those two and tell me whether you see a difference between the two, right? You can see even the one on the right, it's more elaborate, right, in terms of its definitions, right? An expression is not only defined now in this case as just an expression, but we go even deeper by defining a term, okay? Now, the reason why we are defining a term again is because we don't have that, we don't want to have the brackets, right? Because in our human language, right, all we have to do is to just include the brackets and say that these and these are inclusive of those brackets. And because of that, whatever is within the brackets is on a higher order as compared to whatever is outside the brackets, right? So in this case, how we enforce that is by including an term, at each subsequent precedent term. Okay, so that is what I'm talking about. Okay, so at each level of where you want to enforce some form of precedence, okay, introduce an terminal item. Okay, and that's the reason why you can see that there is an inclusion of a term now when we are defining an expression. So an expression in this case is not only defined as an expression, operate expression, but now we are defining it as an expression plus a term. Then we say, or it can also be an expression minus a term, or it can also be just a term. Okay, and that will also be part of our homework today. Okay, I want you to go and break down now this line that we had, the one that we had, x -2 multiplied by y. Now don't follow these rules that we have here. Follow this one. Okay, try and follow this one. I know by now you've had some basics. Just follow this and see whether whatever you'll have derivation, the derivation that you'll have, okay, will be common, whether you use leftmost or rightmost. And even better, go ahead and create a pass tree for leftmost derivation and rightmost derivation and tell me whether it will be similar. Okay, and I think we can pick from there next week. Unfortunately, we have not been able to talk about ambiguity. Allow me to discuss about that next week. It will be something short that I'll discuss there together with other items when it comes to something like the passing techniques. I'll talk about them just a few minutes before the next class, and then we can cover whatever is needed for that class. Anyway, I hope you've enjoyed the class. Oh, in terms of a small task at the end, it's always good. Yes. I'm trying not to overwhelm you with a lot of lab work. So after this one, we are going to take a break from lab. So for today, I just want you to go and look for this. Okay. for this. You can either source it online, or you can design a simple scanner and then just get the output of that scanner using the simple rules that we followed last week. Okay, and then save it in that folder, and then in 2 weeks' time I'll be able to ask you to share that folder. I'm going to create either a link or a Google Drive where you're going to share, and then I can give you the marks based on what you've done. Okay, on top of that, if you feel that was too easy and you want to do some bonus rounds to get 3 points, just try and get a hold of Lex. It's an open source tool for developing lexical analyzer, and anything you do with it, attach for me and I'll be able to give you 3 points. Okay, I hope that is okay. Good. If there are no questions, you can all go do the lab. Also remember to do the CAT. So the CAT is due on 29, probably even tomorrow midnight. I think I should. Users will be taken in terms of time and all that. Good. I don't see any questions, so I'm going to hang around for the next 1 minute. In case you have a question that you remember, you can ask. If you don't have a question, you can leave. The class is over.